Now we are going to study enzyme biotechnology. What is enzyme biotechnology? Now, firstly, what are enzymes? Enzymes are large macromolecules containing large proteins. Enzymes are large macromolecule in which large proteins are present. The function of enzymes is nothing but it speeds up the chemical reactions. So it is also called as biocatalysts. Enzyme is obtained from a Greek word by the scientist Wilhelm Kuhne in the year 1877. The properties of enzymes are speeds up the reaction. It speeds up the reaction. So acts as biocatalyst. It is also can't be destroyed. It is used in either direction, either forward or backward direction. And these are the molecule which acts on all the different types of molecules. Cofactors are non-protein molecules which activates the inactivate enzyme. Cofactors can be of three types: activators, coenzymes, and prosthetic group. Activators, coenzymes, and prosthetic groups. Now, we will know about the factors affecting enzyme activity. What are the factors affecting enzyme activity? First is concentration of enzyme substrate product, and also temperature, pH also affects the enzyme activity. Activators also affect the enzyme activity. Enzyme activity is directly proportional to velocity, and as the concentration increases, velocity of enzyme increases. Concentration of effect of enzyme increases with velocity of the enzyme. Temperature should be optimum. Optimum temperature is 40 to 45 degrees and the optimum pH is 6 to 8. Now, as the concentration of product increases, enzyme activity decreases. These are the factors affecting enzyme activity. Now we are going to study enzyme immobilization. What is enzyme immobilization? It is a technique. Enzyme immobilization is a technique in which an enzyme is confined to a inert solid matrix which stops the movement of enzyme. The enzymes is attached or confined to a inert solid matrix which prevents the movement of enzyme. This technology is known as enzyme immobilization. Enzyme biotechnology is a process of modification of enzymes and produce improved version of enzymes. In enzyme biotechnology, we modify the enzymes and produce improved version of enzymes. How we provide improved version of enzymes? By modifying its structure on catalytic site. Now we are going to study the enzyme immobilization advantages. After the advantages include, firstly, enzyme immobilization. First immobilized enzyme is amino acylase. It is prepared in the Japanese. So it produces L type of amino acids. And this technique is improved. This technique is helpful for the increasing in function efficiency of enzymes. It helps in improving function efficiency of enzyme. It enhances reproducibility of enzyme. Immobilized enzyme can be reused and have continuous use. The contamination of enzyme will be less. The enzyme will be stable. The stable supply of product is obtained using enzyme. High enzyme substrate binding ratio will be high. So the advantages include, firstly, first enzyme immobilized is amino acylase, which is useful for the production of L type of amino acid. And another advantage is it is helpful for the increasing the function and efficiency of enzyme. It is also helpful in enhancing the enzyme activity, enhancing the reproducibility. We can use the immobilized enzyme and have a continuous use. We can reuse it. It gives more stability to the enzyme. Stability to the enzyme will be more, contamination will be less, and stable supply of the product is obtained. stable product can be supplied using enzyme, and the enzyme substrate binding ratio will be high. These are the advantages. Disadvantages of the enzyme immobilization are it is high cost. For the isolation of enzyme, purification and recovery costs are very high. Industrial application is limited for the immobilized enzyme, and some enzymes will be unstable. Enzymes are inactivated by heat generation. These are the disadvantages. High cost, industrial application limited, some enzymes are unstable, and also enzymes are inactivated by heat generation. Enzyme immobilization. For the enzyme immobilization, we need a carrier or an inert solid matrix. We need either a carrier or it also called as inert solid material or inert solid matrix because enzyme is attached or immobilized using a carrier. Now the ideal properties of carrier are the carrier should be inert, it should have low cost, carrier should be eco-friendly, and it should have thermal and mechanical resistance. It should be highly stable. It should enhance enzyme specificity, and it should also prevent protein adsorption and denaturation. These are the ideal properties of a carrier. It should be inert, low cost, eco-friendly, and it should have thermal and mechanical resistance. It should prevent the protein adsorption and denaturation. It should be highly stable and carrier should enhance the enzyme specificity. These are the ideal properties of carrier. Now carriers are of types of carriers. Carriers are of three types. Firstly, based on the morphology, based on the inorganic nature, based on the organic nature. Carriers based on the morphology are porous and non-porous. Based on the inorganic nature are glass, silica. Based on the organic nature, they are natural, synthetic. Natural are alginate, collagen, pectin. Alginate, collagen, gelatin, while synthetic are polystyrene, nylon, PVC. So these are the types of carriers based on the morphology, based on the inorganic nature and the organic nature. Based on the morphology, porous and non-porous. Based on the inorganic nature, glass and silica. Based on the organic nature, they are natural and synthetic. Natural carriers are alginates, collagen and gelatin, while synthetic are PVC, nylon, polystyrene. And now we are going to study methods of immobilization. The methods of immobilization are adsorption, covalent bond, entrapment, cross-linking or copolymerization, encapsulation. Absorption. Now I will repeat again. The methods of enzyme immobilization are 5 types. Absorption, covalent bond, entrapment, cross-linking or copolymerization, and the last is entrapment. Now, adsorption is further divided into 4 processes: static process, dynamic process, reactor loading process, and electrode position process. The methods of adsorption are further divided into four types: static process, dynamic process, reactor loading process, and also the last one is electrode position process. And covalent bonding is also of 3 types. Firstly, one is diazotation, peptide bond formation, polyfunctional reagent use. Diazotation, peptide bond formation, polyfunctional reagent use. And the next is entrapment. And in the entrapment, four are there. First is inclusion in gel, fiber, and microcapsules. In entrapment, 4 processes are there. First, inclusion in gel, fiber, and microcapsule, and the last is entrapment, immobilization by entrapment with porous matrix. First, we will come across one by one. First is absorption. Absorption is nothing but the carrier. In absorption process, the carrier used should be inert and insoluble. So, in the absorption process, the carrier should be simple and widely applicable. The carrier used is simple and widely applicable, and there is no permanent bond formation. The enzyme just adsorbs the carrier molecules. The carriers involved in the adsorption process are mineral, organic. Mineral are aluminium oxide and organic are starch. Mineral or aluminium oxide and organic is starch. In static process, enzyme solution is mixed with carrier without stirring. While in dynamic batch process, carrier is placed within the enzyme reaction with stirring, with continuous stirring. In a reacting loading process, carrier is placed in the enzyme solution in a reactor where continuous stirring occurs. The fourth process involved in the adsorption is electrode position process. In this, the carrier is placed in the enzyme solution in an electrode containing bath. A bath containing electrode in this enzyme and carrier is placed. They are mixed, and electrons are migrated, which produces current. Due to this production of current, the disposition of enzymes over the carrier takes place. These are the four types of production or processes involved in the adsorption process. And the next is covalent bonding. The advantages and disadvantages of adsorption process. The advantages include: it is an easy process. Minimum activation steps are involved. It is cheap. Enzyme disruption is not happen. Enzyme disruption do not happen, and pore diffusion limitation is not there. So in the adsorption, the advantages are: it is easy, it is cheap, minimum activation steps are required, and the enzyme disruption is not there, and no pore diffusion limitations are also not there. Next is disadvantages are: desorption may happen, efficiency is less, temperature and pH weakens the bond. So the disadvantages of adsorption are: desorption may happen, temperature and pH may weaken the bond, and efficiency is less. Next is the covalent bond process. In covalent bond process, the carriers involved are carbohydrate synthetic protein, amino acid, inorganic, and cyanogen bromide. The carriers involved in the covalent bond are carbohydrate synthetic protein, amino group inorganic, and cyanogen bromide. In the carbohydrate, cellulose agarose. In carbohydrate involve cellulose agarose. Synthetic involve polyacrylamide gel. Protein involve collagen gelatin. Amino group involve aminobenzyl cellulose. Inorganic involve glass and silica gel. Cyanogen bromide involve an agarose. Carbohydrate involve cellulose agarose. Synthetic involve polyacrylamide gel. The protein involve polyacrylamide. The protein involve collagen and gelatin. Amino acid involve aminobenzyl cellulose. Protein are collagen, gelatin. Carbohydrates are cellulose agarose. Inorganic are silica gel and glass. Cyanogen bromide is nothing but agarose. Enzyme is attached to the carrier with the help of covalent bond. In this also three processes are involved: diazotization, peptide bond, and polyfunctional reagent process. In diazotization, amino group is attached with the tyrosyl group of enzyme. Amino group of carrier is attached with the tyrosyl group of enzyme. In peptide bond, amino group or COH group is bind with tyrosyl group of enzyme. In peptide bond, amino group or COH group is bound with tyrosyl group of enzyme. And in the polyfunctional reagent, many polyfunctional groups are present, like alpha amino, alpha COH, beta gamma COH, phenol ring. These all groups bind with the tyrosyl group of enzyme. This is involved in the covalent bonding. Now the advantages of covalent bonding are there is no strong the advantages are strong linkage is present. So no leakage happens. Strong linkage is there. It is commonly simple and widely applicable. It supports the molecules with different functional groups. The advantages of covalent bond are it have strong linkage, no enzyme leakages happens, comparatively simple and widely applicable. It gives support to the enzyme with various different functional groups. Now the disadvantages are because of the functional groups, chemical modification of enzyme may happen. Only using covalent bond method, only a small amount of enzymes are immobilized. Chemical modification is nothing but conformation changes occurs in the enzyme which may lead to inactivation of enzyme. So these are the disadvantages. Advantages are strong linkage, no leakage, simple, widely applicable, and support the molecules with different functional group. But disadvantages are due to the functional group, modification in the enzyme may happen, and only small enzymes are immobilized using this process. Entrapment is nothing but, in entrapment, porous matrix is used. Water soluble porous matrix is used. For the entrapment process, the carrier uses water soluble porous matrix. Here the enzymes are physically trapped in a solid matrix. No, in this covalent or non-covalent bond may be involved with different type of enzymes. According to that, different solid matrix are used. We have to adjust the pore size because enzyme in entrapment, we have to adjust the pore size because enzyme loss may happen. Now next is carriers. The carrier used in the entrapment are gels, cellulose, gelatin, agar, alginate. Polyacrylamide gel, cellulose, agar, alginate. The carrier used in entrapment are polyacrylamide gel, agar, gelatin, alginate. Now the methods used in the entrapment are inclusion the gel, inclusion the fiber, microcapsule, entrapment by enzyme immobilization by entrapment. First is inclusion in the gel. Semi-solid gel is used in which enzyme is included. In fibrous matrix, enzyme immobilization happens. In the microcapsule encloses the enzyme and causes enzyme immobilization. The advantages are these are faster, cheap, easy to practice, mild conditions are required. For the enzyme immobilization by entrapment, advantages are these are the faster process, cheap, easy to practice, and mild conditions are required. Faster, easy, cheap, mild conditions are required. Conformation changes do not happen. It is used for sensing application. Next is disadvantages. Leakage may happen. Pore diffusion limitation is there. And the next is microbial contamination may happen, and industrial process success is not there. So the advantages are faster, cheap, easy. Conformation change do not happen. Sensing application used for sensing application. Disadvantages are leakage happen, pore diffusion limited, microbial contamination may happen, and in industrial process not much success is seen. In the cross-linking or copolymerization, no carrier is used. Immobilization is done with a reagent containing functional group. So these reagents help in the forming covalent bonds between the enzymes. No carrier is present. Reagents are glutaraldehyde and diazonium salts. The advantages are cheap, simple, used in industrial method. Cross-linking is cheap, simple, and used in the industrial process. The disadvantages are there is a chance for conformational change. Next is encapsulation. In encapsulation, carrier is not used, but semi-permeable membrane is used. In cross-linking also, carrier is not used. In encapsulation, a semi-permeable membrane is used which is made up of nitrocellulose and acts as a capsule, and enzyme is enclosed in it. The advantages are simple, cheap, large quantity of enzymes can be entrapped. For the advantages of encapsulation are simple, cheap, and large quantity of enzymes may be immobilized. The disadvantages are pore size limitation happens. In encapsulation, pore size limitation is there. In entrapment also, pore size limitation is there. Next is kinetics of immobilized enzyme. Normal enzymes, immobilized enzyme varies from normal enzymes behavior. V0 is directly proportional to Km. So there is no need to know about the kinetics. Now applications of the enzyme. We can use them for biosensors, in medical field, in diagnostic agent, food and dairy, textile and biofuels. Applications of immobilized enzymes. We can use them as biosensors in the medical field, diagnostic agent, food and dairy, textile and biofuels. We can use immobilized enzymes in biosensors, medical field, diagnostic, food and dairy and textile and also biofuels. Biosensors, food and dairy, textile, biofuels and diagnostic agents, medical field. These are the applications of enzymes.